Good morning all. Now we will have module 3 section 2.5 ordinary differential equations. This is the overview of our presentation. We have the differential operator D and Euler-Cauchy equations. The differential operator D is denoted by capital D, where capital D is d by dx and d square by dx square is capital D square. That is, dy by dx can be written as capital dy, d square y by dx square can be written as capital D square y square. Now let us have Euler-Cauchy equation. Euler-Cauchy equation is a differential equation of the form ax square y2 dash plus bx plus cy equal to 0, where a, b, c are constants and y of x is the unknown functions. We substitute x equal to e raised to z by considering x not equal to 0, so that the given differential equation can be written as am square plus b minus am plus c equal to 0. Here we have this is a second degree equation, therefore we have three cases. Case 1, real different roots. Case 2, real repeating root. Case 3, complex roots. In real different roots, say m1 and m2, our solution is y of z equal to c1 e raised to m1z plus c2 e raised to m2z. Then corresponding solution is, now we have the second case, a real double root. Then y of z is c1 plus c2z into e raised to mz. When case 3, when complex conjugate roots, say alpha plus or minus I beta, we have y of z equal to e raised to alpha z into c1 cos beta z plus c2 sin beta z. Thank you.